NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new.
All these little dots are galaxies, some of which are bigger than our own. Space is more crowded than you might think, and actually galaxies wind up interacting with each other. They actually will merge together. The most distant galaxy in the universe, the one that is the furthest away from us that we currently know about. I'd like to share that with you.
Peering deep into the universe's past, into the very first moments after its birth, astronomers have uncovered something astonishing. NASA's James Webb Space Telescope has revealed hundreds of unexpectedly brilliant objects blazing in the darkness of cosmic dawn, far brighter than theories predicted. The finding has scientists both thrilled and perplexed, challenging long-held ideas about how the earliest galaxies formed. Recently, a team of astronomers from the University of Missouri, wielding the extraordinary power of the James Webb, uncovered something truly astonishing. 300 mysterious, intensely bright objects scattered across the distant reaches of the universe. These aren't just any cosmic curiosities. They may well be some of the very first galaxies ever to exist, beacons from a time when the universe was only a few 100 million years old. This finding, published in the Astrophysical Journal, has the potential to upend everything we think we know about how galaxies form and evolve. Up until now, our best models predicted that the earliest galaxies would be faint and rare, their light barely detectable after traversing over 13 billion years of cosmic expansion. Yet, here they are, 300 bright candidates, shining far more brilliantly than expected, challenging the very foundations of cosmic history. The key to understanding this breakthrough lies in the phenomenon astronomers call redshift. Picture the universe itself expanding, stretching space and everything within it. As light from distant galaxies travels toward us, it's pulled along with the swelling cosmos, its wavelengths lengthening, slipping from the visible spectrum into the deep infrared. The higher the redshift, the further back in time we're looking, sometimes nearly to the Big Bang itself. To put this into perspective, when astronomers detect a galaxy with a redshift of, say, 10 or 12, they're seeing light that has traveled for more than 13 billion years. That light left its source when the universe was in its infancy, just a few 100 million years old. The James Webb Space Telescope, with its ultra-sensitive infrared instruments, was designed precisely to peer into these ancient epochs, and now it's delivering on that promise in spectacular fashion. Detecting such distant galaxies is no small feat. The further you look, the fainter and more elusive these objects become. But the James Webb has a secret weapon. Its ability to spot the faintest glimmers of light shifted into the infrared. Lead researcher Bangjeng Tom Sun and his team used a clever method known as the dropout technique. Here's how it works. Astronomers scan the sky for objects that are bright in redder wavelengths but completely vanish in bluer ones. This sudden dropout is a powerful clue that the object's light has been stretched so much it no longer registers at shorter, bluer wavelengths. This technique hinges on a cosmic signature called the Lyman break, a sharp cutoff in a galaxy's spectrum caused by hydrogen gas absorbing ultraviolet light from young, hot stars. As redshift increases, this break moves steadily from the ultraviolet through visible light and eventually into the infrared bands. By carefully analyzing which parts of the spectrum are missing, astronomers can zero in on galaxies from the very dawn of time. But while the dropout method is a powerful tool for finding candidates, it doesn't provide definitive proof. To truly confirm the distance and age of these objects, astronomers turn to the gold standard, spectroscopy. By spreading a galaxy's light into its component colors, much like a prism creating a rainbow, scientists can measure its redshift with exquisite precision. This allows them to pinpoint just how far that light has traveled, and therefore, how old the galaxy truly is. Of the 300 mysterious objects detected by Webb, at least one has already been confirmed as an early galaxy using spectroscopy. Its light began its journey not long after the universe's first fireworks, the birth of stars and galaxies, illuminated the cosmic darkness. But what about the rest? If even a fraction of these 300 bright candidates are genuine, we may be on the verge of rewriting the textbooks on cosmic history. Why is this such a big deal? Existing theories suggest that galaxy formation was a slow, gradual process. The universe needed time for clouds of hydrogen to cool and condense, for the first stars to ignite, and for those stars to gather into the sprawling structures we now call galaxies. The brightness and apparent abundance of these newly discovered objects suggests something far more dramatic, an era of rapid, intense activity, where galaxies blazed into existence much sooner than anyone predicted. This discovery is more than just a catalog of distant dots in the sky. It challenges our understanding of how quickly the universe's first stars and galaxies appeared, how they grew, and how they shaped the cosmos that followed. If confirmed, these findings could force astronomers to rethink the timeline of cosmic evolution, from the birth of the first elements to the formation of the large-scale structures that fill our universe today. The James Webb Space Telescope, with its unprecedented sensitivity and power, is opening a window into an era previously beyond our reach, a time when the universe was just taking its first breaths. The implications are profound, not just for astronomers, but for anyone who has ever gazed up at the night sky and wondered how it all began. What makes this discovery so astonishing is not just the sheer number of these objects, but their luminosity. These 300 mysterious bright sources, scattered across the ancient universe, are far more luminous than our current models can comfortably explain for such an early epoch. According to the prevailing theories, the universe's first stars and galaxies should have taken hundreds of millions of years to assemble and shine with such brilliance. Yet the James Webb Space Telescope is capturing images of galaxies that appear fully formed, burning brightly, when the universe was just a tiny fraction of its current age. To understand why these findings are so significant, let's revisit the concept of redshift. As the universe expands, light from distant galaxies is stretched, shifted toward longer, redder wavelengths. The higher the redshift, the farther back in time we are looking. With JWST's infrared eyes, astronomers are now able to spot galaxies at record-breaking redshifts, peering back over 13 billion years. The objects in this new sample show some of the most extreme redshifts ever observed, suggesting we are witnessing the universe as it was less than 500 million years after the Big Bang. But how do astronomers pick out these ancient galaxies from the thousands of objects in JWST's breathtakingly deep images? This is where the dropout technique comes into play. Essentially, astronomers look for objects that drop out or disappear in certain shorter wavelength filters, specifically the bluer parts of the spectrum. As a galaxy's light travels through the cosmos, it passes through clouds of hydrogen gas, which absorb energetic ultraviolet photons, creating a sharp cutoff known as the Lyman break. The more distant the galaxy, the farther this break is shifted into the red part of the spectrum. By comparing images taken in different filters, astronomers can spot the telltale signature of galaxies from the cosmic dawn. Yet, finding candidates is only the first step. To truly confirm their distances and their place in cosmic history, astronomers turn to spectroscopy. By spreading the light from these galaxies into a rainbow of wavelengths, they can precisely measure the redshift and confirm just how far back in time they are looking. Out of the 300 candidates, one galaxy has already been confirmed using this gold standard method, solidifying its status as an ancient beacon from the dawn of the universe. The rest await further confirmation, but even a handful of true early galaxies would be enough to challenge our fundamental understanding of how structure forms in the cosmos. If these findings hold up to further scrutiny, the implications are nothing short of revolutionary. It would mean that galaxies began assembling, forming stars, and shining with intense brightness far earlier than expected. The first stars, known as population 3 stars, might have formed and lived out their brief, brilliant lives in a cosmic blink, seeding the universe with the first heavy elements and paving the way for more complex galaxies to arise. It could also suggest that our models of dark matter, cosmic inflation, or the behavior of primordial hydrogen need to be re-examined. This is the kind of discovery that fuels the imagination and propels science forward. Every new image from the James Webb Space Telescope is not just a snapshot of light, but a message from the universe's earliest days, challenging us to rethink what we know and pushing the boundaries of our curiosity. The work has just begun. Spectroscopic confirmation of these objects will require more time, more observations, and more analysis. But even as astronomers carefully sift through the data, the excitement is palpable. We are living in a golden age of cosmology, where instruments like JWST are allowing us to peer back to the cosmic dawn itself. Each breakthrough brings us closer to answering some of the most profound questions ever posed. How did the first stars ignite? When did galaxies begin to form? And ultimately, how did the complex, beautiful cosmos we inhabit come to be? As the James Webb Space Telescope continues its mission, we can expect more surprises, more mysteries, and perhaps even more discoveries that challenge the very foundations of our understanding. The universe, it seems, is always one step ahead, waiting for us to catch up, to look deeper, and to ask new questions. If you're as captivated by these cosmic mysteries as we are, make sure to like this video and subscribe for more content like this. The journey into the unknown has only just begun, and together we'll keep exploring the wonders of the universe.